So yesterday we learned about substitution, which we use if we can isolate for a variable easily, like if the coefficient of one of the variables is 1 or -1, or if one of the equations is already has a variable isolated for. Now today we're going to look at elimination, and pretty much elimination you can honestly use any time. Okay, there really aren't restrictions on it, but what you do want to have in your equations is all of the variables and terms lined up. So I want the x's lined up, the y's lined up, and the constants lined up, either both to the right of the equal sign or both to the left. Okay, so we're going to go through the steps together, but the basis of elimination is that you want to eliminate a variable, and the way you eliminate a variable is by matching the coefficients so that you can add or subtract them later on to get rid of them altogether. Once you get rid of one variable, you're just left with the other one and you can solve it easy. Okay, so first step we're going to do, label our equations as 1 and as 2. Okay, now we're going to pick either x or y, and that's the variable we're going to isolate for. Okay, so let's say I want to isolate for y. Okay, I want to eliminate y. Okay, if I want to eliminate for y, I need to find the lowest common multiple. So between 5 and 1, the common multiple would be 5. Okay, so the lowest common multiple of the y is 5. And now I need to multiply both lines by a number so that the coefficient becomes this target. For the first one, I don't have to do anything. I'm just going to multiply by 1. For the second equation, I just have y. So if I want to get it to become 5y, I have to multiply by 5. Okay, so my first equation stays the way it is. 6x plus 5y equals 32. The second y, every single coefficient is going to be multiplied by 5. So that I have 5x plus 5y equals 70. Okay. Now, if I want to eliminate my 5y's, I have to ask myself, should I add the positive 5y's or should I subtract them? 5y plus 5y is 10y. I haven't eliminated anything. 5y minus 5y, that's perfect. That becomes 0. So we are going to subtract the equations to eliminate the y. Okay, so 6x, I'm just going to rewrite my equation. 5x, notice everything is lined up nicely. And now I'm going to put a line across, and I am subtracting. Now I'm going to subtract each line. So 6x minus 5x is just x. 5y minus 5y disappears. I don't have to write it. 32 minus 70 is negative 38. And there's my x. Okay, and I'm done. I've already isolated for x. There's nothing else I can do. Now, the rule of thumb is if for the variable you're trying to eliminate, if the signs are the same, you want to subtract your lines. If the signs are opposite, you want to add your lines. Okay, so now we're going to substitute x equals negative 38 into equation. I'm going to choose equation 2. Okay, it's a lot easier to deal with because the coefficients are all 1. And when I do that, I'm going to solve for y. So I have x, which is negative 38, plus y equals 14. And now I can bring this negative 38 to the other side so that it becomes addition. 14 plus 38. And I get y equals 52. And there's my point of intersection. Negative 38, 52. Okay, now I solved for y in equation 2, which means my left side, right side check is going to come from equation 1. And equation 1 told us that 6x plus 5y equals 32. So I know what my goal is. Now I'm going to just sub my numbers in. So 6 times negative 38 plus 5 times 52. Okay. 6 times negative 38 is negative 228. and 5 times 52 is 260. And now when we add those two numbers, we should get 32, and we do. So that's perfect. Okay, so to recap over here, elimination, you want to eliminate a variable. Choose the variable you want to eliminate, multiply both of your equations, one of the equations, whatever it may be, so that the coefficients match, and then you want to add or subtract your equations to eliminate that variable. And now you just have x or y, you can solve for it, and then you're back to the substitution steps where you substitute that x or y value to solve for the second missing variable. Now in this example here, we could have actually used substitution because we could have isolated for x or y really easily in equation 2, but that's what I was saying about elimination. You can use it whenever you want. There aren't as many restrictions as there are with substitution. If we look at example 2, we will notice that none of our coefficients are 1 or -1, which means we have to use elimination so that we avoid fractions. It makes life a lot easier. So what we're going to do, I labeled my equations 1 and 2. Now what we want to do is choose a variable. Let's say we want to isolate x this time. If I look at 4 and 3, I have to ask myself, what is the lowest common multiple of 4 and 3? It doesn't always have to be the lowest common multiple. Technically, the shortcut, just like you find a common denominator, 4 times 3 is 12. Okay, so my lowest or my common multiple is 12, which in this case is also the lowest one. Okay, you want to find a number that I can multiply 4 by something to get 12, and I can multiply 3 by something to get 12. Okay, so for equation 1, I have to multiply 4x by 3 to get 12, and for the second one, I have to multiply 3x by 4 to get 12. And again, you're going to multiply the entire equation by these numbers. So I'm going to write it a little longer. I'm going to write my original equation first. This is how I usually show it. And then I would say, put brackets around it and say that I'm multiplying it by 3 for the second one. Again, I put brackets and times 2. And now I'm going to write my new form right over here. 4x times 3 is 12x. 3y times 3 is 9y. 3 times 3 is 9. There's my first modified equation. 3x times 4, 3x times 4 is 12x. Negative 2y times 4 is negative 8y. And negative 19 times 4 is negative 76. Okay, now I look at my 12x's. They're both positive. To eliminate them, I'm going to have to subtract. Okay, I'm going to write my equations again. And then I'm going to subtract them. With subtraction, really be careful. Make sure with those negatives. Okay, so 12x minus 12x, that's gone. 9y minus negative 8y. So that's two negatives, which is going to become addition. So it's really 9 plus 8, which is 17y. And then 9 minus negative 76 is 9 plus 76, which is 85. And now we can divide both sides by 17, and I get 5. Y equals 5. And now I can sub this y equals 5 into either equation, 1 or 2. And I'll just go into 1 so that I can solve for my x variable. This step is very similar to substitution. So I have 4x plus 3 times 5 equals 3. So 4x plus 15 equals 3. We can bring that 15 over, and when we do, we have 3 minus 15, which is negative 12. Divide out that 4, and negative 12 divided by 4 is negative 3. So our solution is negative 3, 5. Okay, technically because I used equation 1, I really only need a left side, right side check for equation 2, but just to be safe, you can do it with both, and we'll just do that right here. to get more practice with left side, right side checks. So 4 times -3 plus 3 times 5, that's -12 plus 15, and perfect. I have 3, which we expected. Let's try the second one, because this is the one that's really going to determine if we're right or wrong. So we have a -9 minus 10, and that's perfect. Left side equals right side. So there we go. There's elimination. Okay, choose your variable, multiply both equations or one equation, and then eliminate that variable by adding or subtracting. Actually, right here, I'm going to make a note. If we want to add or subtract, same sign. So like we have 5x and 5x, we want to subtract. If we have an opposite, so one of our coefficients is positive, the other is negative, we want to add. Okay? Okay, I'm going to have you try example 3 on your own. Use the steps if you have to. Try to do it on your own, and then we'll take it up. So just pause the video right here. Okay, so your answer should have been 2, 0. Now, I chose to isolate for y. If you chose to isolate for x, that's totally fine. If you got 2, 0, that's perfect. If you didn't, this is a great learning opportunity. Try to find your mistake. Okay, so if I chose y, my lowest common multiple was 6. So I multiplied the first equation by 3 and the second by 2. So I had 12x plus 6y equals 24. 10x minus 6y equals 20, and this is what I was talking about before. My signs right here are opposites, so I add my equations. 12x plus 10x is 22x, 6 plus -6, perfect, it's eliminated. 24 plus 20 is 44, and I get x equals 2. Then I chose to sub it into equation 1, and I got y equals 0, and then because I subbed into equation 1, I checked with equation 2, and it all worked out, so that was perfect. Okay, so for elimination, choose your variable, multiply your lines to get that lowest common multiple, add or subtract, get your first variable, sub it in to get your second, and you're done. Now, between substitution and elimination, it's always a preference. Some people prefer substitution, some people prefer elimination. You need to know both, but obviously there might be one that you prefer more. And personally, elimination, it's always going to work for you. Substitution, sometimes it's just going to get too messy.